going to tell you a little bit about AutoScout, then how we are changing in AutoScout, what's actually happening there, and how we are building our microservices, what's our way of doing that, and how we are organizing ourselves while doing that. So you probably don't know AutoScout, but AutoScout is like AutoTrader. There's no real difference. This is the listings business for used cars, so you place an ad for your old car and you can buy old cars from there. This is a 3,000 feet, 30,000 feet overview. In the center of everything is specified, which is then searchable and displayable, and you can put it on the watch list, and there's also stuff that's producing those listings. So what's important for us is to recognize that this part over here is mostly read traffic and doesn't have a lot of business behavior, and we are writing over there, and this is where we are actually currently working on. So we are working on the read side of our platform, and the writing part is still in the data center. And this is how AutoScout looked like. It's still looking like in parts and looked like 2 years ago. So we had a very good IT setup. We had our own data centers. Everything was optimized. Our processes were good. The platform was working. We were highly available. Could handle all our load. Product was very happy with us because we were delivering features and products very, very good. So we had all the lean and agile ingredients a company needed. But it was still, from a hardware perspective, it was an enterprise setup, and this also reflected back on the software side. So in essence, we were relying on that the mean time between failure is optimized for VMware, Oracle, everything is high available with redundant power supplies, but not how the modern cloud setup works, and the teams were not ready for that. And despite that we liked the setup, something changed. AutoScout was sold to private investors, and a new CEO came on board in the beginning of 2014, and he asked questions. Some of those questions were, are you ready for the 21st century? Do you have a good setup there? Is it everything working? We said, yeah, this is great, we are a good company. And then one question puzzled us. It was the question, do you attract talents? And you need to know we are a Microsoft shop, or were at that time a Microsoft shop. So .NET, Windows in the data center, and we were able to hire good .NET developers, but they mainly came from an enterprise background. So in Munich, there are banks and insurance companies, and they have a lot of .NET developers, which are really good, but they don't know much about the web, and so we took them on, we have to learn them stuff, and they didn't bring in real good ideas, which brought us forward, which made us think a little bit more. This is how we thought about this. This is our technology ecosystem flywheel, and when you look at that from a .NET perspective, there is good technology, excitement, community, and talent, which all feed to each other. But in the end, when you look at the same ecosystem in the JVM world, it's bigger and it's faster. And this is, we realized that, and we had a discussion beforehand about Kafka and .NET, which also was something which we tried to introduce Kafka, and there weren't .NET drivers for that. Then we sat there and said, should we now write our own drivers for .NET and Kafka, and this doesn't bring any business value to us. So in the end we said, we need to change something. And this was the start of Project Tatsu, as we call it. You saw in the beginning the roller coaster. The roller coaster is also named Tatsu. This is how this project feels like. This is a roller coaster. So everything changes for us. What we are doing, and this we started in November 2014 with this project. So we are going from monoliths to microservices. We are moving from our data center to AWS. We are leaving behind .NET and Windows and going to JVM and Linux. And we are going from a dev and ops silo with different departments to a DevOps culture or a collaboration culture. And we also try to heavily involve product people along the journey. By picking the JVM, we also made a decision as being a .NET shop that we couldn't upgrade our developers from C# to Java. We need to offer them something fancier for them to actually pick it up, so we've chosen Scala as our starting language. And this is how we see our technical migration should look like. So even in the data center, we have started carving up our monoliths into swim lanes. Those swim lanes are not real services, they are still sharing the same integration database. Part of this is just brute force copy of the monoliths with carving out stuff and adding functionality, but it gained us improvement in delivery cycles. So those swim lanes could be delivered fast, and this helped us. But we believe now that we should carve out further vertical slices and rebuild them as microservices with JVM on AWS. And this in itself is not an easy problem to solve, but we also need to solve the problem not at a pit stop where we can stop the application, but while the whole thing is running. So this needs to go on. And when introducing a lot of changes like that, we believe we need something we can hold on to. And we came up with those architectural principles, which you can't read it right now, but you shouldn't also not dive deep into those. But our architectural principle and our design and delivery principle should all align with our strategic goals. And this helped us tremendously because now we can focus our discussions. The mere process of coming up with those principles helped us shaping our thinking and have a common understanding how we would like to work together and how we go on with our technology. And this is printed out and is in every team room. We have those principles, and when in doubt, they can look up and have discussions around those things. And this is also an ongoing process. The principles are continuously changing. There are different or another strategic goals coming up, and we need to reshape and redefine principles, and we're also dropping our principles. So this is an ongoing discussion which helps us very much. And please don't copy them. These are not your principles. These are ours. So you can pick and choose one of those, but it's important for you to come up with those principles that fit your technology stack, your culture, and live those and not just use ours. I will go a little bit deeper in some of those principles, for example, organized around business capabilities. We believe that our teams and their microservices they are going to build in the future should build around the business capabilities. So we try to talk about products and not projects, and this goes back to the domain-driven, design-bounded context. So the stuff that's going on within a team and within their service should be as self-contained as possible and be a business capability. We also believe in you build it, you run it. This goes back to having those devs and ops silos. So the devs were writing code, and if this code breaks on the weekend, the poor ops guy has to be on the page, and this is not how we want to roll. So the teams are not only autonomous, but they should also be responsible for what they are building. And you build it, you run it meme is then also to extend it that they're also responsible for the product they are building and the improvement of the product they are building. Another interesting one is be bold. So we believe that we want to go fast. One of our core strategic goals up there was reduce time to market. So mainly most of the things we are doing pays to being fast, having fast feedback, and for that you also need to be bold. This means going into production early. Don't sit on your new service and test the hell out of it before going into production, because experience tells it will fail in production in ways you won't anticipate and can't test for in prior stages. So you need to be bold to go out there. And this also means that we optimize for mean time to recovery and not on mean time between failure. So we need the capability to recover. So we might make failures, but we need to recover them. This also means that we are stronger, more invested in semantic monitoring, meaning we have user journeys that constantly walk our site for the important things that are going there, and not too much rely on tests that are run while we deliver new stuff. Because in production, stuff can happen for different reasons. There is always a disclaimer: when being bold, don't be stupid. So there should be ways that you're mitigating risks that are in there. So for example, we are looking into doing canary releases and putting shadow traffic on our services. So currently we have the advantage of being mostly on the read side, so we don't have to care that much about modifying data, which allows us to put every service shadow live. So it's hit by a percentage. Most services ramp up to 100% really soon, while still not being feature complete and visible to the customer. So the page that, for example, is behind the product is still served out of our monoliths from the data center, but all the requests are also shadow back to the new service being built. And so the team has the advantage of not actually being surprised when later go user facing. So we actually didn't have any hiccup when switching from an old service to a new service, because all the load testing and all the thing that goes on was already there. So the fourth thing I want to go into, when we're talking about microservices, for us it's very important to actually be very clear what's part of the macro and what's part of the micro architecture. So in essence, there are a lot of decisions a team can now make without consulting anybody outside of the team. This is the autonomy part, and they need to know what kind of decisions they can make, but still they need to be good citizens within the macro architecture, and therefore some parts of our system we define as macro architecture. Typical, this is things like monitoring, logging, security, parts of the delivery, and data contracts. So all the things where we need to integrate services with each other, or there are availability concerns around that. And the last one was quite controversial, and actually on the latest version of our principles we rephrased it a little bit, but I still like the original version of shared nothing. Of course, there is also a disclaimer: there is stuff you need to share, but the default should not be to share. The default should be not to share. And to make the thought process work, we put in the stronger wording of share nothing there, and I will go a little bit deeper into that one. So when thinking about shared infrastructure, we also try to not share too much infrastructure. There is a few things I mentioned already, but there are other things we initially tried to share, which brought us problems. So we had a central dashboard service. It was written in Ruby, and it had global state, and then we had two dashboards by two teams, and they shared their requests per minute, which wasn't good, because somehow this part became global state. So they were looking at the requests per minute for their service and were seeing completely different measurements depending on when they looked at it. So in essence, there is few infrastructure in between there that's actually shared. We have convenience offering, what we call it. So our delivery pipeline we build, and most of the teams are using it, but we don't force them to use it. So if they find a reason to build a different delivery pipeline, they still need to adhere to the principles of our delivery pipeline, but they don't need to use the implementation. But as teams are lazy, they have other things in their mind, they will just use the convenience offering. The no side effect story I already told about the dashboard service, and this goes back to whenever you share something, you don't have the freedom of fast local decisions. When you're not sharing stuff, you can iterate fast. So for example, AutoScout has a sister company in Berlin called Immobilien Scout, which is almost in the same business, but not for used cars, but for real estate. And there is the discussion, should we now share stuff between them? And every piece that we pick out will become a discussion, what we actually want to do there. And this is not a good place to be. But nevertheless, we need to respect our family ties, so we need to find some places where we actually then do stuff across AutoScout and Immobilien Scout. And also when sharing, we believe that, so this happens at least within AutoScout all the time. A developer does something interesting the first time, he believes this needs to be a library, this is the best thing ever written, and everybody will use it if it's only shared and put out as a library. So in the .NET world, they built a lot of NuGet packages for everybody to use, and they went into the JVM world, and Maven Central was all the hype, but we didn't want to do that. So we said, please use it before you try to think about reuse, and please make this part actually be hardened and stabilized before you put it out as a shared library that we use across the teams. And also think about different ways of sharing stuff. Sometimes if it's only one class or some lines of code, copy and paste is not a bad thing. And also when think about sharing, the pull principle, like the typical open source mantra, I can pull in open source from other teams, but it's not pushed at me. I'm not forced to use it. I will use it if it fulfills a need. When talking previously about being bold, also the notion of how we deliver it is important. And the question came up, how we actually deal with those different versions of those microservices and how we stage them. And we also learned that production always differs from our staging environment. Previously at AutoScout, we put a lot of effort into to have a staging environment that is as close to production as possible. So of course, the delivery into those environments broke then for reasons because it was different for production, so we had to fix them. And when then going into production, the software might also break because still the load patterns on production are different. And when thinking about testing versions in those different environments, so if I would have version number 5 of the yellow service successfully integrated with version number 2 of the blue service in the staging environment, and then would promote my yellow service to production, it would be now integrated with version 1 of the blue service. But I've tested it against version 2. And when you deliver many services with different versions all the time, you will always have a hard time building a staging environment that actually has the same version of your dependent services in there as production. So we decided to skip the staging completely. So stuff is built from the engineer. We have our commit stage, and then in our dev environment, the service is instantiated for the first time. It's put on an EC2 instance and started. And if this works, then we directly go into production. But going back to, we don't want to be stupid. This would be like the old days, just push into production and hope for the best. So as I already told you, we are heavily going into shadow traffic, and we are now also thinking about shadow traffic for services that actually change data to somehow flag the data that's generated by shadow traffic as being test data and not use it for production. We are employing a concept called consumer-driven contracts, which I won't go deep into it. If you're interested, you can pick me up afterwards or Google it. This essentially helps you to have in every stage a mock available to you, to which you can verify your service against, and you run the contract tests of the other services that you behave as they expect before going into the next environment. I already mentioned also the semantic monitoring. So when we don't heavily invest in testing before that, but when the services are in production, we try to look at the whole system, not the individual service, and try to make meaningful user journeys over those services so that the experience for the user works. And also what currently we are only at the stage of doing smoke tests before starting our services in production. But we are looking into doing canary releases also before going there.
Any questions?
Any questions on that? Can you hear me, by the way? This with the microphone, this is... Okay, good.
So, I was going to say, we do something similar there. We used to have tons of stage environments. We now have, I think, just, well, we have two. We have Sandbox 1 and Sandbox 2. They're somewhat equivalent to your dev environment. But do you always make sure that it can deploy into that environment? Do you insist that it must deploy into that environment, or do you just go straight to prod? Like, is it possible to ignore that dev environment?
So this is, for us currently, as we are not doing canary releases, the first time actually the services started at all. So this currently this needs to be in place, and over there it's actually not allowed for this service to actually integrate with the other services. So in this environment we don't make sure that all the dependent services are available. So they use mock services, or they just use, if there are not services but databases, with test data, but we are not trying to integrate all of those services. This is difficult in the beginning because developers like it, so they are always pushing. If they introduce something in production over here, the next thing would be, oh, I need to provide that also in dev, and then you're back to square one. Then you have to provide all those services in two environments, and it won't help you much. Yeah.
You brought up an interesting point of schema migrations and data stores. So how do you go about maintaining and running different structures in your database between versions? I mean, what you displayed there is anything between, well, 5 different versions. And so if you have schema migrations that need to structurally modify the data, how big is your window before expansion and contraction, and how do you keep track of that?
So we are not that heavy currently in database schemas, because we are mostly on the read side, which is mostly simple DynamoDB tables, more like key value stores. But we did something similar in our data center, and this was very early on, decoupled code and database releases. So initially there was the big release every 4 weeks, and then the changes to the database were applied, and then the changes to the code, or the other way around, and there were scripts before the code delivery and scripts after the code delivery, and everyone hoped for the best, and we really decoupled those. So it always needs to be forwards and backwards compatible, which might mean that you have an additional step where you introduce something new before you can take away the old one, which takes another delivery. But database deliveries are completely decoupled from the service releases. And this is, same goes for all kinds of APIs or data contracts we are looking into. So there needs, if you come into the realms of lockstep releases, then I believe you've got lost. Does it make sense? Yes?
I don't think I got fully how do you release, because you were saying, like, initially when you needed to release, let's say, V6 that depended of the yellow one, that depended of V3 of the blue one, how do you do that now?
So if this one is dependent on this one,
yeah.
So
and it's not going to work with V2 of blue one.
So you need to make sure. So this would then go into the realms of CDCs, but in essence, the short answer would be the blue service. If the yellow service wants to integrate with the blue service needs to provide a contract that works against the yellow service, and he needs to provide a contract for version 3 and version 2. And in this environment, I can verify that I'm working against version 2 and I'm working against version 3, and then I'm only allowed to go to the next version. So this goes back to the schema and database versioning, which also goes back to the API versioning. You need to make sure that before you go into an environment that your contracts fulfill the service you're expected to meet there. And it's the responsibility of the blue service to provide the test that the yellow service fulfills the contract as expected. Yeah?
Sorry, you just said that you have to make sure that the V6 layer 1 is compatible with V2, right? But how can you make it? How can you test it without having that feature in the dev environment now?
So, this service expects something from V6, and when he expects this behavior, he needs to write a test that verifies that contract. And so this service is writing tests against this one, and this service needs to execute those tests before going into the appropriate environment. So it's the inversion of control. I'm writing tests as a consumer against the service that's providing the API, and it's the responsibility of the service that's providing the API to run the tests of all consumers before going into an environment where those consumers in a specific version show up. There are quite some interesting tools out there that can help you with that. There is Pact from RIA in Australia, and, which is based on the JVM. There's Pacto for the Ruby world, and it's also written up in some blog posts on Martin Fowler's wiki, etc., which dives deeper into that. And it also includes the opposite, so when writing those contract tests, it also includes a mock, so that this service can use a mocked version of the other service in the environments where he does not have to or does not want to integrate with. Okay, I briefly talk about our logging infrastructure. When we started in our data center, we just have Splunk. So all the log files go into Splunk, and we spend a lot of money. And we said we want to improve on that. So in the center of everything, those are Kinesis streams. So think Kafka if you're not familiar with AWS. And we are collecting all those logs that AWS is writing to S3 and pushing them through our Kinesis data pipeline. And we will also do that with system log that are written on the instance. So this would be one of those service instances. But the most important part for us are those application events. So we decided that our applications are no longer writing log files, which are then shipped off to Splunk or via FluentD or into the Elk stack, but they publish structured events, being JSON objects, directly into Kinesis. This gives us the advantage that there is no log parsing or anything new in there, and those events are actually very machine readable, and they go through together with all the other logs, and they're in the end through Kinesis, and there is a Lambda which you can think of as just a listener on those Kinesis events, which then executes a function and can write them to different stores. So we're writing them to an S3 bucket, which is the foundation of our data lake. So everything that's happening is persisted as events in S3 for data analysis later, and also put into a managed Elasticsearch cluster which runs Kibana, and there you can have all the diagnostics you need on those events. So this helped us very much getting rid of a lot of indirections in here, and also provide meaningful data to our data scientists to build further products on the same way, because it's way easier if you think about objects and what is interesting to a future use case, what's happening right now. So we put all the correlations ID in there. And just briefly mention another thing which we also like. So when talking about production, it is for us not allowed to make any manual change to production. So part of our delivery pipeline is not only the service, but also the complete infrastructure that is part of the service and also the infrastructure of our global stack. Which means that we now could put an alert on CloudTrail, which is an AWS service that tracks all the changes to infrastructure. And we have a simple alerting on that. If any change to production is introduced, not via our delivery pipeline, we get an alert. Unexpected production change. Somebody fiddled with the console and changed something which we don't like. We like infrastructure as code. Only repositories and the delivery pipelines are allowed to change the infrastructure. And this also goes to our logging pipeline. Any questions on that? Yes.
It seems that you are completely dependent on Amazon Web Services.
Yes! So, going back, this is one of our principles. So, because you could get it completely the other way. You could only write on compute or something like that. But when going to the cloud, we decided we want to be fast and we want to use those higher level services. And we actually don't want to, in the beginning of the project or program, invest in abstracting away AWS. So our mantra is, if there is an AWS service that fulfills the role, pick it. If there's no AWS, pick a managed service, and only then begin looking into open source or hand-roll your own. You can question that, and I don't say this is the right answer for you, but for us it's the right answer, and it helps us tremendously because you have a good starting point, and a lot of those higher level AWS services provide a lot of value. You just have to insert coins. Yes, but this is the promise of the cloud. Don't do the undifferentiated heavy lifting, so we rely on that. Still, we don't try to be stupid. If there is something an Amazon service can't do properly, we don't use it. But up until now, there was no reason not to use an AWS service. Yes?
How many accounts in Amazon do you use? Do you have one big fat account for all of your stuff, or do you have an account per team or an account per team of teams? Any structure?
So currently we have, within AutoScout, we have one dev and one prod account.
Right.
And for example, those log files live in a different account, so logs live in a different account, audit lives in a different console, and so some of those, we have a tools account, so those are carved out as separate accounts for security reasons or for stuff like that. Our sister company, Mobilien Scout, is heavily looking into one account per business capability, not necessarily team, but somewhere around that realm, which shows up some difficulties. Going back to the discussion, then it's not that easy anymore to use AWS services for everything, because then you're in the cross-account realm and stuff like that. But in essence, for me it's the same reasoning as for microservices. So I have a microservice, and now I give the team freedom and autonomy for this deployable artifact. But if I then later also give a team of teams perhaps and a separate account, they can be very autonomous within and have a hard shell surrounding all the services. Even if they would try to, they can't affect other services. So this is an idea we are also looking into, but currently we go the easy way with one production account for all teams. But each team has their own stack within the production account and their own security group. So this works. But we will expand that probably. Yeah. Yes?
Can you tell us something about the application events? What kind of events are they, and how are they?
So for example, we have a service that does price valuation. So you just enter your make and model and what you know about your car, and then it tells you what we are estimating this car is worth. And whenever you do that, of course, there is sitting Google Analytics on top of it for some of those properties. But when those values are entered into a form and posted back to the server just writes out an application. And now somebody with the following visitor ID to somehow track the people selected the following properties and we return the following price and writes that out. Which later gives other people a way to actually optimize the whole price valuation tool, because they can now look into it, what cars are actually mostly looked after for those prices. And this goes the same for almost every request or behavior that's happening within those services. It's not only writing out a line like a web server does, there happened a request on the following URL, but it includes all the context it has that might later on help us to correlate stuff and know what's actually happening in the system. Yes?
When you talk about infrastructure delivery pipeline, are you talking CloudFormation or did you?
Yes, mostly. So we have CloudFormation and we have an open source tool written by ourselves, AutoStacker24 sitting on top of it, which is just a Ruby glue code that allows us to forward the output parameter of the parent stack into the child stack. So we have a global stack that defines the networks and how the global stuff actually works, and then each service brings its own stack that is part of the global stack and defines its infrastructure, its databases, and its security groups in there.
Cool.
Okay? Then when integrating our data center with AWS, we looked into data pumps and events. So of course we've got the big Oracle back in our data center, cluster and master-slave replication, and all the important business stuff is still happening in there. But for driving the read part of our application, we need those data in AWS. So what we have built, similar to the data pump, data bus from LinkedIn, we've built some tooling that allows us to pull the changes out of the database and publish those as events to AWS to feed them off the query part. And this is for us more or less a one-way data highway. So the leading system is still the data center, the query part is in the cloud, and we push events from the data center there to use it. In the future, when looking into the right part, some teams of us have already looked into patterns like CQRS and event sourcing. This would allow us to only reason about events in the future and don't have those big RDBMS sitting around. And when thinking about those data pumps, this is an example how it looked like, and this is for us one of the early success stories when going to AWS. We were iterating over all those options, what we could do. So the first thing was, we're talking about events, you need a queue, so you pick SQS, and you need to write them somewhere, so you pick S3. And we spiked and had prototypes of all those different scenarios. Within 2 weeks, everything we tried, thrown away, had new ideas. In the end, we just simply used DynamoDB, and looking back, it's so simple that I don't know how we could come up with different solutions. So within the data center, we're just writing against DynamoDB, which is publicly available, and all the events go in there, and we're done with it.
When you drop them into the database, so one of the ideas that we had originally was just throw it all into some kind of store. Don't worry about the structure, just throw it there. And then it creates like a data sludge rather than a data lake. And so now we're looking back at that kind of going, well, how do you don't know how useful the data is going to be. So you want to give some indication of what the structure is, and then just pump stuff there. I'm just wondering, how do you define the structure of the events?
Okay. So for those events, it was rather easy because we were talking about our classifiers and everybody knew how they looked like. But when going back to the application events, I was pulling one of the data scientists in and had a look. Does this make sense to you? And he immediately asked, what is this property? Where are all the other events from all the other applications? Oh, we need to look into those repos to find those events. We haven't implemented a solution yet, but the idea is our events currently, as being in Scala and having written an event publisher for that, are typed events. And we will, similar to Java doc, attribute those with the necessary metadata. And when a service starts up, it will publish an additional event, which is the metadata for the events he's publishing. And then you only have one way how to publish those events and extract the metadata to be consumable for those interested in.
Yeah, great.
So I will skip that one. This was a success story of our watch list. Something which made very much sense for us is when talking about those vertical slices, most of our current microservices include the UI. So we will rethink that a little bit, but in the end, a team is a full stack team, and therefore it's not only supporting an API, but it's also delivering a UI. And when you then have many pages delivered by different teams, the end user using our platform should know that there are different teams working on our platform. So we need some kind of front-end integration so that we only have the header ones and the footer ones, and also there are some overlaps where it makes sense that a capability of a different service appears on a page owned by a different team. So we looked into the realms of front-end integration and UI composition, and also looked at our principles. So we still wanted to have a shared nothing architecture, which meant for us that the front-end UI composition part couldn't be a smart thing. If this would be too smart, we would build a monolith, a mini monolith in front of our vertical slices. And we want to give as much autonomy to the individual services as possible and not couple them too tightly to our integration. Something important for Autos code, previously our swim lanes were all routed via a separate host entries, so we wanted to go the one domain route, and we have very much load on our pages. So, and the user expect them to be fast. So in the end, the Google page speed index should stay up even with this solution. This is what we came up with. So we've put CloudFront in front of all our services. If one, CloudFront is the CDN from AWS, and if we touch a path that we didn't migrate yet to the new world, it just goes back to the data center and delivers the page from the data center. And if you find, okay, this is a new service, it's already on AWS, we use our front-end layer, which we call Jigsaw, which has an Nginx in the middle and just an ELB in front of it. Those services are actually different services, so these are not load balanced services, but actually one could be our home page, our listings, our detail page, and stuff like that. So the Nginx knows how to call all of those. What's then happening, and this is a little bit of the magic in there, every one of those services that's called by Nginx includes, in Varnish it's called, I believe, edge side include, and then the Nginx it's called server side include, and so the yellow part would be, for example, the detail page, and the gray part would be the contact form, which would be delivered by a different service. And of course, the page itself would bring its own CSS and would bring its own JavaScript. And the contact form also should bring its own CSS and its own JavaScript. This pays back to those teams should be autonomous, and they don't want to couple them via a big asset pipeline where they have to push their new CSS over there and only afterwards are allowed to deliver their new page. And then there comes a magic from Google, mod page speed, or in the Nginx world, Nginx page speed. And what this does is, it doesn't actually know that this was composed. It's just seeing, oh bummer, those guys were stupid, they were scattering their CSS and JavaScript all over the page. So let's just recombine that and put the CSS on top and the JavaScript on the bottom, and out comes a page that has a very good page speed. So in essence, we deferred the asset pipeline completely into runtime behavior. Because every service brings its own assets, and the Nginx page speed then fixes all the stuff that's going wrong when doing this approach. And it works quite well up until now.
So what happens if the outer page is using a different version of jQuery? Or
Yes, so
those problems?
So, our UI experts decided to go with vanilla.js, so no heavy frameworks, and they are currently working that a part of this page would be the header, and those common libraries would be part of the header. And then you still have the discussion about versioning. So this, if the team decides up there is a particular version and you need a different version, then we haven't tried that one out, but I believe it would still then be possible to actually load a different version via a module system like require and use just that. But this wouldn't be the ideal solution. You're not getting rid of some of the problems you have when integrating different widgets on the same page, but you're mitigating some of those.
On the previous slide, you had a single Nginx in front of all your services. Is that not like a single point of failure if that Nginx goes down, your entire site goes down?
Yes, it is. And so we still have one cluster of Nginx in front of all our services, but there is currently the discussion because this is more a dumb appliance, which don't have much smart. I can put one of those in front of each of those services or in front of a group of services that inherit the same SLAs. So nothing speaks against it, it's just a little bit more effort to do it like that, and we didn't introduce it, but it's possible, yes? So, I've mentioned many times now the autonomous teams, and this is something which is very, very important for us, and especially when talking about introducing the devs and ops into the same team. So we now call ourselves all engineers. There's no developer and no operations guy anymore. But this was a very difficult endeavor for us. We had very strong silos, and there was a lot of finger pointing going on in previous times. And when then introducing operation guys into those full stack autonomous teams, we actually need to take care of that. And sometimes we saw things we called the Mandelbrot team. So previously you had the big silo ops dev, and then you were going into a team, and the 5 devs were sitting on the left side, and the 2 ops guys were sitting on the right side. Those 2 were doing infrastructure, the other were building the service, and they were not talking with each other. So we need to do many iterations over that one, but in the end it worked out, and all the guys really love it. So we have now engineers that were previous developers who are doing a lot of infrastructure work, and we now have ops guys who actually love their product, and this works very well. And we tried many things to work that out, but in the end for us now it's important that the team in itself is cross-functional and full stack. Not everyone in that team needs to be that. So we don't have all full stack developers. We acknowledge everybody has a T-shape and everybody has his spike or his deep experience somewhere else, but in essence the team must work it out. And when talking about infrastructure, we initially, and we're still working like that, we don't have a shared infrastructure team currently. So all the shared infrastructure work is also done inside of the product teams. So they now have two products. One team, for example, is doing the price valuation, but is also responsible for the logging infrastructure. And we try to avoid shared infrastructure, but there needs to be some, and we founded a infrastructure guild where those those shared services are actually talked about, but those guys are not doing any work, they're just talking about it, and the actual work is then done in the teams themselves. And this helps us, and the platform or shared services team is working, but this approach helps us that we are actually building the right infrastructure that the teams need versus having an infrastructure team that tries to build services with the best intention, but not actually what the teams need. This is the last slide, so hopefully we are in time for the pizza. This is the last challenge I want to talk about, that we are having two stacks now. So the money mostly still earned on what we call the cash stack. And yes, we didn't want to call it legacy. This would be nice to the people working there, because if they're fed up with the legacy cash, it wouldn't flow. So this is interesting. So we try to live that we are still one company. We have the mantra of we need to keep the lights on in the cache stack, and we try to minimize the time in between where we need to support both stacks by having feature freezes on stuff we are moving over, and by doing things like the UI composition I showed you, we also enable product to have more or less the decision where to build new features, because we can integrate both stacks very well. And this is an ongoing endeavor. So this would be the end. Thank you very much. And now, with the pizza in the back, there might be some questions still. Just go ahead.
Pizza.